Hey everyone. Yeah, good morning to the people who are still in the morning, and good afternoon to who is in afternoon already. So yeah, my name is Akhil Reddy Bairi, and today I will be presenting the topic of quantum leap in quality, and it's basically like um, harnessing quantum computing for a digital era. There are a lot of words in this, but yeah, we can start with um, situation. Like I can just share a situation. Most of us QA are aware about it. So just imagine a scenario where you are leading a testing effort for a major software release. Yeah, at that point, like the product is very huge, and there will be a lot of user paths which we need to verify, and also like as it is a major release, like there is also where we have to verify with multiple devices and multiple configurations. And as always, like we can't the time the timeline is tight, and yeah, at that point your team will be stretched thin trying to cover as much as possible in the time which they have. So despite the best efforts which we try to put into testing that major software release, there is always some bugs keep slipping into the production. And based on the industry which you are in, like that bugs can cause major costs and that are associated with those bugs. So yeah, every day feels like a race against time, right? Because we have very less time. It's always busy, and we need to complete that part of testing in certain time, and we have a limited resources. And there are many scenarios that may take some long time to test. So those are all the difficulties actually we face in a regular basis as a quality assurance specialist, right? So just imagine if there was a way to explore the every possible test scenario that is possible, not just one by one, but all at once, instantly, which reveals like all the riskiest areas of the application, so that we can focus on that particular one. And just imagine if that is possible, and that would turn the weeks of testing into minutes. So just imagining itself feels good, right? So it may sound like a dream which we are trying to achieve, but yeah, there is one technology which is a cutting edge technology that is turning that dream into the reality these days, which is making a true quantum leap in how we assure the quality. So you might be wondering like what is this quantum leap in quality, and what is this quantum computing, and how it's going to change on the processes and the quality assurance. And we might also be wondering like how is that going to impact the way we work, right? Like just like the technologies which we are seeing these days, like at some point of our life, like we have heard just words of AI. Okay, there is a word like AI. If you look into the past 10 years, there is just AI just started and it developed. And nowadays, like again, we are at a stage, is AI going to replace us, or like what's going to happen to our jobs and all this stuff, right? So before we get answers for these questions, let's step back and look at a bigger picture, the current challenges we have in the quality assurance. Let's begin our presentation. Yeah, introduction. So, digital transformation is sweeping across the industries at an unprecedented pace these days. Like there is a lot of new technologies which are happening in all the fields, and for each field, there is a lot of QA effort that is needed to make sure like whatever the technology we are using is doing the right thing which it is supposed to do, right? So and also there is a large improvement in the scale of the industries. Like if you compare, if you just take an example of a manufacturing company or automotive, basically a company which has, if you look at the data of that particular company, there is a lot of data which is being generated, like every space of that particular company, right? Like the sensors, it can be a logs, or it can be user interactions that happens in the company. If you look at the data at an overall process, there is a large amount of data, right? So to make sure that whatever the data we have is right, and to make sure that we have the quality process to verify such volumes is a very big challenge these days. And traditional QA methodologies, obviously, we can't test those complex systems, like because there is a lot of things that needs to be tested, right? So and it also needs that to be tested with a higher accuracy. So with the traditional QA methods, it is really hard to test these massive amounts of data. So here in this quantum computing, it represents a fundamental shift to verify all these processes. It's not just the faster way; it also fundamentally changes how we solve the actual problems itself. Like even in the implementation of different applications and calculations, it changes how we approach the problem solving. And also that can be also be applied to a quality assurance process, so that it will be helpful in figuring out the issues earlier. So for this quantum computing, like the governments worldwide, they are investing a lot of money, like they are investing billions of dollars every year to push this quantum technology from research to get into the real world applications. So even if you can just go to Google and search, and the quantum computing programs which are being implemented by the government, so that like they can achieve the progress in their country in this particular technology, as this technology is that powerful. So and obviously it is in the earlier stages right now. So to put the numbers just in the perspective, like the global spending on the digital transformation, it is projected to be exceed like 3.5 trillion by 2027. Whereas like in that particular 3.5 trillion market, um, here it is just like the quantum computing, it occupies a major part. Like it's the expected value is like 1.7 billion. So this is basically according to a survey conducted by the IDC company. So it's almost half almost like major amount, like in which of 3.5 trillions, like 1.7 billions is like a major part of the chunk, right? So they are trying to invest a lot of money into this particular technology, which means that like we can understand by this investment of bigger amounts of money, we can it's very clear that the quantum computing is important, and it is moving from the actual theory space to a practice. Like if you see, there is a space called quantum physics from a long time, but again there have been improvement through all these years. But yeah, now we are trying to take that theoretical knowledge and trying to put into the practice. So again, to put into the practice itself, now we are in the early stage of this process. So if we are going to implement this quantum computing in the QA processes, like I imagine like if you are simulating thousands of scenarios at the same time, like, and we'll be able to optimize our tests. That's really the great promise that can a quantum can offer, right? So that would really help us in verifying the upcoming technologies in an easy way. So before diving into that, let's understand on what quantum computing is and why it's different from the classical computing which we have right now. So coming to the quantum computing, it's unlike the classical bits, which is like a zeros and ones, which we use in the classical computing. We are using the qubits, which can be zeros or ones or both at the same time because of a feature called superposition of a qubits property. So it is like spinning coin that is simultaneously which can have heads and tails until it lands, right? So that is one of the features of the qubits that would really help us in the parallel processing. And there is also another critical property called entanglement, which is basically if there are multiple qubits, they can be linked so that the state of one, it would influence the state of the other regardless of the distance. So this is a really I would say a different feature that would help us in solving the complex problems. And yeah, this feature, this was identified early in earlier days itself. Like even Einstein, he was surprised by looking at this particular feature of qubits, and he called as spooky action at a distance, because like these qubits can be placed at a multiple distance, but they are very much linked. So that is main part of the quantum computing. And in the zeros and ones, which is the classical computing, we use gates, which would where we create the logics of our processing, right? So in a similar way, there are also quantum gates, which is used to manipulate the qubits so that they also preserve the quantum information. And yeah, coming to the building of qubits, that is a really huge technical challenge that we have right now, because there's to build this qubits and to see the expected outcome from the qubits. They require very ultra cold environments. It's like how like the evolution of computer has started, right? Like in the very earlier days, like the computer needs to be in certain temperature, certain atmosphere, so that like it would do the calculations and it used to be very huge in the initial days, like how a initial computer was, right? So now like qubits, it is in the similar stage again, but there has been a lot of improvement in the research of the qubits. So there are multiple companies which are trying to get into this field, and they are trying to create qubits based off of different technologies. Like IBM and Google, they use conducting circuits. There is a startup called IonQ. They use trapped ions, and Pascal that uses neutral atoms. So each technology has a different strength in terms of qubit fidelity and scalability. So the largest quantum computer we have right now, it would be is built by IBM as far so far. Like that's the largest quantum computer which we have as of now, and I think it has around 1,000 qubits, around which is like a 1,100 or something. But yeah, that's the largest quantum computer which we have right now. And to start on this particular technology, we don't have to get all that hardware to be built in our companies, right? So here, because there are cloud platforms which is like IBM Quantum Cloud, and I think Amazon Bracket, they are offering a service as for this quantum, and also Microsoft offers the Azure Quantum service, which would help us to run our algorithms remotely, so that like we don't have to get the software. It's like a cloud service which is being provided by these companies, so that we don't have to get all the setup ready to at least start working on that. We can get the services from this company and start at least start our application and see how it works. It's like again like how we are getting the cloud services, right? Like we'll be able to get a subscription from them so that like they provides a backend for us. So yeah, to implement, like there are multiple frameworks again, Qiskit and Circu. Uh, these are based off Python. So most probably like it is accessible to a lot of developers today. So if anyone wants to start on that, probably it is a bit easy rather than like looking at a very different language. It is based off Python. So yeah, just a fact of this quantum computing, I think like back in 2019, I guess, Google, they announced that they were able to achieve quantum supremacy, performing a calculation that would take like around that calculation would have taken around like more than 10,000 years using the classical computer, but they were able to achieve it in 200 seconds. So that's the potential that quantum computing holds. And again, it's not like we have to use the quantum computing at each and every level, but there needs to be a specific application that can be applied to, and also we have to be using it in an efficient way. And there are also there are also many problems that quantum computing can also uh, can't solve, right? So it's not like it's a super thing of whatever are the problems which we have right now, but yeah, definitely it is helpful in some of the problems which we have right now, which can't be solved with the classic computing. So yeah, so why the quantum matters for QA? So as I said earlier, like your traditional QA, we have a lot of problems with the massive data verification and the complex workflows, and also there are some specific processes where we have to verify in a multiple variables approach. So that it is really hard with the setup which we have right now in the traditional QA, but with the quantum, it provides the advantage by exploring all these possible solutions simultaneously, and it also accelerates the AI model training and optimization, enhancing the pattern recognitions in the bug detection and also in the predictive analytics. Uh, Usually, like when we link this particular quantum computing with the AI, it will be able to. It is very easy to train the data for the AI also, which will be helpful in the prediction of our application, like bugs in which is in our application. So that is would be a really game changer, I would say, for a QA, because like it will be able to identify the problems early stage itself, so that we don't have to wait until a certain time to get that solved. So I believe like JP Morgan, they have implemented some process. Again, it's not a complete quantum computing process which they have implemented for that, but they have quantum inspired algorithms which they try to improve, and they said they were able to reduce the bugs by 30% in their sector. So yeah, looking into the QA areas that quantum can impact. Firstly is the test case optimization. So yeah, for this, like as I said, quantum can efficiently identify the minimal test set that is needed for our scenarios. Like based on the code we have, like it will be able to identify what test needs to be done, and it can save a lot of time. And even a company called Volkswagen, as they have also used the quantum inspired algorithms to optimize the traffic flows. And they have also mentioned that they were able to reduce the testing time drastically by that. And next, the bug prediction and the root cause analysis. It can also benefit from the quantum machine learning, which can again they can detect the patterns in the code bases that classical methods often miss. Yeah, coming to the performance testing at a scale, it can be transformed by the quantum simulations. Quantum computing offers a simulation which can allow to test it with extreme conditions, which was not possible with classical tools like the tools which we use right now. Again, there is a lot of development which have been happening in even in our regular testing tools too. But yeah, this would add another advancement layer if we use that. And finally, with the security testing, it is critical because there is, again, I would say there is a different aspect of security for this quantum computing, because the quantum computing, it can break the encryption methods which we have right now, the RSA and all those methods actually that can be easily it can break these encryption algorithms. So there is also, again, I would say, there is a background work which have been doing by by the organizations to look into that, because if you implement this in the larger scale, it would definitely a problem with the security. But there are also standards which they are developing so that it can be useful. It cannot break the things which we have right now, and it can make sure that it is available with the things which we are using right now. So yeah, the same with the predictive maintenance, because of the quantum enhanced AI models. It can anticipate the failures more reliably, reducing the cost overall. So coming to the real world applications, quantum computing is already impacting the industries today. Yeah, first one is the pharma. So in the pharma, we'll be able to simulate the molecules, which would help us in finding the drug discovery. So this particular application was already started. I think a company called Roshi, they have leveraged the quantum simulation for the drug discovery for oncology treatment. And they mentioned that they were able to um, uh, reduce the clinical research times by around 50%. That would be a really lifesaver. And also by this means that like we'll be able to find the potential life-saving treatments to the patients faster, so that like we'll be identifying the drug discovery in very less time than the regular methods. So that's really a big thing in the pharma, because they rely on implementing the drugs, so that it would help us help the patients with the treatment for the um, diseases which are new every day, right? So that would really help in the faster way of providing the drugs in the research phase. Yeah, coming to the logistics, it will be able to uh, it can find the global route and load optimization, which is basically like, would help the logistic companies like DHL. They are using some of the quantum algorithms to optimize their supply chains. It is also used in reducing the delivery times and lower costs. Quantum can solve the complex routing problems. I'm not sure if you might have heard, there is a salesman problem where we need to find the optimal solution of traveling from one distance to other distance, right? There may be a multiple ways, but yeah, that can be solved. And for that, like there is the efficient answer can be provided with the quantum computing in that particular sector. And coming to the finance part of it, sorry, so the cybersecurity, the post quantum encryption method is being added. As I said, there was the problem with the quantum that can break the encryption method which we have right now. So there is also post quantum encryption method that can be used, so that it will be it won't be able to be break by the quantum and the classical methods. So that is also being implemented. And yeah, coming to the finance, there is risk modeling and the fraud detection. A global company, I think it's Goldman Sachs, they are partnering with the IBM and some of the startups to apply for the portfolio optimization, and which is aiming to improve the returns by 5 to 10%. And also the company called BPVA, they are also testing the quantum pilots focused on the credit scoring and also risk profiling. Additional to that, like this, quantum computing is also being used uh, in the energy firms. They are trying to, in the energy firms, it is important to find the grid load balancing, and they are also using to find the optimal way to use the energy which they are receiving. So just like a solar panels, right? They won't be able to use the maximum amount of energy which they have got, but yeah, by they are also researching on how to make an effective use of the light which they are retrieving. So additional to that, like there is also a lot of research which is happening in the defense field too, because there is a technology called quantum communications, which will be possible um, to in the defense, to make it like the without knowing to the other person, they will be able to communicate with the other sources which they have. So that would be a definitely benefit to in the uh, defense defense sector. So these are all the real world applications we have. And yeah, QA plus quantum is quality 4. So yeah, we are using a lot of new technologies these days, but yeah, I would say like the quantum will be the next feature which we are trying to, which will get into the feature of the implementation into a quality 4, quality, which will make it a quality 4. So based on this implementation of quantum with QA, it's definitely going to reduce the times with the identification of issues, and also it will help us with improving the quality, I would say. I think like the company called Siemens, they have already implemented in improving the quality approach with the combination of quantum. So yeah, going to the challenges and current limits we have. Yeah, I think I have already added a point before that, like the quantum hardware, it's still maturing, and it's there is a lot of noisy and error prone, because like a small change in the surroundings may hinder the performance of the how quantum computing behaves. So yeah, and it so we can also, it's also possible that to build the hybrid models where we can where we can combine the quantum and classical methods, because implementation of like entire thing using the quantum computing may need a lot of energy resources that way. It's better to have that implemented with the combination of quantum with the classical. And also there is a lot of skill gaps right now in the quantum computing. I believe there is around like 10,000 professionals which we have right now in the worldwide. But yeah, that can be improved for sure. So we need to make sure that we are ready, like if this going to be helpful for in a company level, right? So to get that to which is like a quantum computing readiness for that, so we need to have a plan at the company levels to implement. Firstly, we need to see at least what are the use cases of it, and we need to may try we need to try sample POC and see like if it's going to benefit at a company level. And yeah, obviously, like there are a lot of as I said, there are simulators which are available like Qiskit and Microsoft Azure, so they can use these simulators to have a POC and see if it's going to work for them. Again, it doesn't mean that like it needs to be worked for every sector and every company or every application, right? So it is better to have a POC and to see if it works, and if it going to work, we need they can upskill the teams by involving with academy. There are a lot of research programs which happens with the universities, and also companies which are working on the quantum computing, so they can partner with those type of institutions and get that skills in a company. So to look into the future of QA powered by quantum, how it's going to look like, there will be real-time simulations and root cause predictions, and these can be done by the quantum, and there will be smart defect prevention systems. And also there can be systems which self heals based on whatever the defects are. It will be able to self heal the system, and also adaptive QC in autonomous environments. Yeah, so another analysis from the IDC predicts that over like 30% of the organization, they will be piloting the quantum computing by 2027. So it is really important that we need to have an understanding of what it is and if it is useful for the implementation. So yeah, coming to the key takeaways, as the quantum computing represents a transformative leap in how we approach the complex problem solving beyond the traditional computing. When it can definitely help with implementation of QA practices, like a quality for practices, where we can integrate AI with quantum, which can help us in terms of QA in with the real time and adaptive quality assurance. So as there are a lot of investments in the quantum computing, which means that it's definitely groundbreaking technology that will be soon available in most of the companies. So yeah, just if you are interested in exploring, just start and have try a POC and make sure make see if it works for you. Yeah, just the glossary which I have for the terms which I have right now, and yeah, these are the references which I just added for the documents which I referred. And yeah, let's shape the future of the quality together. It's rapidly becoming a practical tool right now for the quantum computing on how we can ensure the quality in the product and services. So the journey we have won't be without challenges for sure, because as it is new technology right now. Yeah, I really encourage you, all of you, to start learning and see what exactly is this technology and how we can make use of this particular technology. Yeah, yeah. Let's see.
Hi,
Mm,
Akhil. This is Lee Thompson, the moderator, finally here. Sorry about that. Some little technical difficulties.
mhm,
We had a couple of questions in the queue, and one I think it was more of a statement. She said quantum coherence equals qubit retaining its information for long enough to do your calculation. Uh,
mhm.
can you explain that a little bit?
So is it the so I'm just trying to um can you repeat that again? I didn't get the exact part of it. So in the quality.
Quantum coherence equals qubit.
Mm-hmm.
Retaining its information for long enough to do your calculation.
Mm-hmm. Yeah, so this is again the feature of the qubits, right? So they will be able to store that um, particular information longer, so that like it will be helpful in getting the calculation faster with the qubits which we have right now. That again, like as I said, there are a lot of challenges right now in the quantum computing, and but I would say there are successful implementations in some particular process, but yeah, I would say there are also challenges in the implementation these days, and again, it's not an easy process to to create the quantum algorithms which would suit for our process right now. Yeah, definitely, I would say it can be one of the challenges for that.
Okay. Another question was while you were discussing qubits, they said like a vector instead of a point. Um, I'm not sure what that was in reference to.
I think they might be considering the um, properties of how a qubit can be worked, I guess.
Can the qubit store more information? I guess that they're adding to that. So,
Mhm. Oh, for the I didn't get that. So qubit can store
so
more.
can the qubit store more information?
As far as I know, like qubit can store information, and again, there are additional processes like the algorithms which they are trying to implement to get the more information. I would say there are there's current research which is going on to make it in an efficient way of storing the information these days.
Okay.
If you're interested, probably like you can look for the journals on the quantum computing, and also there are a lot of even in the YouTube they are providing the current challenges which they have in the quantum computing implementation. And in the same way, like it does work for some sectors, and doesn't have to it doesn't mean that like it will work for every sector. So yeah, there are there is a lot of information on the journals right now with the implementation problems of it. Yeah, definitely. Like again, it's an early stage, I would say. In the part of implementation, like there was a lot of theoretical knowledge which is available in the quantum computing, but now like the practice just started, right? Like in the past, like past 6 7 years, the implementation is being increased. I would say as the implementation is being increased these days, definitely they will be uncovering a lot of challenges, and they will be they are trying to solve the problems which they have right now.
Okay. Anyone else have any questions? We go to 1:45 or 12:45, depending on your time zone here. So, and I know the presentation that you have here will be available. Um, all the presentations that you'll actually see during this conference are going to be downloadable. So we'll have that information. Uh, anyone else have anything else to add to this? Uh, Qubits can be in multiple states, 0 and 1, with the ability to be entangled. But what is the problematic nature?
In terms of like, I didn't get that question. So qubits can be in different states, right? So that is the feature which we are trying to use in the parallel calculations, which is helpful for instead of in a linear process, like we have we do get through each and every particular path which is available, which may take longer time. But as the qubits have this nature of entanglement, it is being helpful in the parallel processing.
Okay. Uh, how can quantum be used for data restore and backup tests?
In terms of, I didn't get that. So, like, are you asking about how it is used in the restoration purpose?
Possibly, yeah, because it says, how can quantum be used for data restore and backup tests? So, yeah, I'm guessing it's the right direction with that.
Yeah, so as far as I mean, like as far as my knowledge, like we are mostly inclined in using the quantum to be able to find out the optimal paths or the solutions which we have right now. But I'm not sure about the restoration and how it can be used in that way, because it has to store that particular information, right? And these days, in these earlier days, quantum computing is expensive, so I'm not sure exactly on how that can be used actually.
Okay. And I think you had shared some links that we can go uh,
Hmm.
to take a look to find more information on this. So, if anyone's interested, when they can get your presentation and go to those links. Um, anything else? We have 3 minutes to close. Well, if there isn't anything else, then we're going to call it uh, an end to this. Uh, Thank you very much. It was a wonderful presentation, and getting some thanks throwing into the queue here. Um, and I'm not sure if I can actually close this out or not since I was having trouble getting in.
Don't
So
worry about that, Lee. I can do that.
perfect. Thank you very much. All right,
Right.
we'll just go ahead and
Yeah.
leave it. Thank you
Attending.
very much, everyone.
Bye.